To solve this equation, we'll take the square root of both sides and note that we get plus or minus 5 as our answers. Before we can take the square root, we have to get the x squared by itself, so I'll simply add 8 to both sides of this equation. We get x squared is equal to 49. Now when we take the square root of both sides, we get that x is equal to plus or minus 7. This one, again, we can immediately just take the square root, and the only real difference here is that we still get our two solutions, but since the square root of 5 is a decimal that repeats forever, this would be the exact answer, just leaving it as the square root of 5. To solve this one for x, you could square out x minus 7, but instead, what I'm going to do is subtract 1 from both sides. We get that x minus 7 squared is equal to 9, and I'm going to take the square root of both sides of the equation. It doesn't matter how much is in the parentheses. When you take the square root, it just reduces to x minus 7, provided that you put plus or minus 3 on the other side of your equation. I will simply add 7 to both sides, and our two solutions are x is equal to 7 plus or minus 3. So you could really break this apart into 7 plus 3, which is 10, and also 7 minus 3, which is 4. All right, I'm going to start by adding 10 to both sides. We get negative x plus 2 squared is equal to negative 100. Okay, now I want to divide both sides by negative 1, which will leave us with the x plus 2 squared is equal to positive 100. Now, when I take the square root of both sides, we get x plus 2 is equal to plus or minus 10. So after subtracting 2 from both sides, we get that x is equal to negative 2 plus or minus 10, which, if we break this apart, it's negative 2 plus 10, which is 8, as well as x is equal to negative 2 minus 10, which is negative 12. Okay, I'm going to start by adding 5 to both sides, which gives us 2 times x minus 5 squared is equal to, 27 plus 5 is 32. Before I want to take the square root, I'm going to divide both sides by 2. And we get x minus 5 squared is equal to 16. Now when I apply the square root to both sides, we get that x minus 5 is equal to plus or minus 4. And adding 5 to both sides, we get x is equal to 5 plus or minus 4. So again, we get two solutions. 5 plus 4, which is 9, as well as x is equal to 5 minus 4, or 1. To solve this equation, I'm going to cross multiply this to the other side of the equation. So the next step is to simply write down x squared minus x plus 7 is equal to x squared plus x minus 1. And all that happened here is I multiplied both sides by this denominator. It canceled it on the left, and it appeared in the numerator on the right, and when you multiply it by 1, it doesn't change it. So this equation becomes pretty simple because you can subtract x squared from both sides. And at the same time, we could do three things at once here. We could also add x and add 1. Putting all this together, we get 8 is equal to 2x, and if we divide both sides by 2, we get that 4 is equal to x. The only thing you'd have to look out for is, does this number make the denominator 0? Because that would not be a solution to this equation. Clearly it doesn't. 4 squared is 16, plus 4 more is 20, minus 1 is 19, so we are fine there. Okay, same idea for this equation. I'm just going to multiply both sides by the denominator, which changes this to x squared plus 2x plus 5 is equal to x squared plus x minus 10. I will subtract x squared from both sides. I will also subtract x from both sides and subtract 5. When I do this and combine it all, I get x is equal to negative 15. Again, I want to be careful that that number doesn't make this denominator 0, but I can see that's not going to happen. I mean, if we square 15. That's huge, and this won't equal 0, so that's it. Multiplying both sides by the denominator, I get that x squared minus 5x minus 1 is equal to x squared minus 6x minus 7. Again, trying to get rid of as much stuff as possible. I'll subtract x squared from both sides. I think I'm going to add 6x to both sides, as well as add 1. And the net result when I do this is x on the left and negative 6 on the right. I just want to make sure that that number doesn't make the denominator 0. It doesn't, so that is the solution to this equation. Okay, I want to be careful here. This time when I multiply both sides by the denominator, I get 2x squared plus 7, but on the right, since it's not a 1, in fact it's a 2, I have to distribute that 2 to every single term. 2 gets multiplied to those three terms. We get 2x squared plus 7 is equal to 2x squared minus 2x plus 6. In terms of canceling the x squareds, this is a good thing because I can subtract 2x squared from both sides. And I think at the same time, the only thing I can do is subtract 6. And I'm left with 1 is equal to negative 2x. Dividing both sides by negative 2 gives me my answer of negative 1/2 is equal to x. I will check to see if it makes the denominator 0. Okay, it does not, so that is my solution. Okay, I want to add these two complex numbers together, which essentially means I'm just combining the like terms. So we have 2 added to 5, and we have I added to 12i. We're saying we have 13i. Okay, when we add these two complex numbers, 5 plus 5 is equal to 10, but 7i minus 7i is a total of 0i, which means we don't have to write it. The answer is 10. If we now subtract two complex numbers, the only real difference here is we want to make sure we distribute that negative to both terms. This is really 3 minus I minus 4 minus 2i. And when we combine like terms, we have 3 minus 4, which is negative 1. Negative I minus 2i is negative 3i, and that is it. Subtracting these two values, okay, I'll distribute the negative, so I get 17 plus 14i plus 100 minus 40i. And let's see, that means we get 117, and then, okay, 40 minus 17 is going to be 26. That is negative 26i. When multiplying complex numbers, we're just going to use the distributive property, which means 10 gets multiplied into the parentheses, as well as I. I'm going to note that if you have I squared, that means negative 1 by definition. So if I distribute the 10, I get 10 times 10, which is 100, minus 10i. If I distribute the I get plus 10i minus I squared. The i's cancel, so we have 100, then we have minus, and I squared is negative 1, which means this is really 100 plus 1, or simply 101. Multiplying these two, I'll distribute the 3, as well as the 2i. When I do this, I get 3 times 3 is 9, 3 times negative I is 3i. Multiplying in the 2i, I get plus 6i, then I get minus 2i squared. I have 9. I have negative 3 plus 6i, which is plus 3i. And I squared is negative 1. Negative 1 times negative 2 is positive 2. When I combine like terms, I have 9 plus 2, which is 11, and then we have 3i. Okay, multiplying these two together, negative 5 gets multiplied to both of those terms. The 2i gets multiplied as well. So this time, we have negative 5 times 3 is negative 15. Negative 5 times 5i is negative 25i. Distributing the 2i, we get another plus 6i, and then plus 10i squared. Combining like terms, we get negative 15. Okay, negative 25 plus 6 is negative 19i. And this time, I squared times a positive 10 means it's minus 10 at the end. So we have negative 15 and negative 10, which is negative 25 minus 19i. Here we only have to distribute one term into the parentheses, but it still works the same way. So 6i times 2 is 12i. 6 times 8 is 48, and we have I squared. But as noted before, I squared is negative 1. This is 12i minus 48. You could reorder this to say negative 48 plus 12i if you want to keep it like our other answers, but that's the final answer. To divide these two complex numbers, we have to introduce a trick. I'm going to write my fraction as opposed to using the division symbol, but the trick that we're going to do here is multiply this by 1. I'm going to write 1 in a special way. Essentially, I take the denominator and I replace it with its conjugate over here. And all that means is it's going to be 3 plus I instead of 3 minus I. When we multiply these two things together, the imaginary part is going to cancel. Now I have to multiply the numerator by the same thing. Now all I have to do is multiply across. So you could put some parentheses in here and just note that we are distributing just like we did in the previous 3 problems. So for the numerator, if I multiply in the 1, I get 3 plus I. If I multiply in the I get plus 3i plus I squared. In the denominator, if you multiply in the 3, you get 9 plus 3i. If you multiply in the negative I, you get negative 3i minus I squared. Okay, combining like terms, let's see. In the numerator, we have 3 plus 4i, and then I squared is negative 1. In the denominator, we have 9. The 3 i's cancel, and I have negative I squared is negative 1, so that means plus 1. We have 2 plus 4i divided by 10. If you break this up into 2 pieces, you can use decimals if you'd like, but 10 gets divided into both 2 and 4i. That's 0.2 plus 0.4i. Multiplying these two together, dividing these two, we have to multiply by the conjugate of the denominator, which is 6 minus 8i. Okay, so when I multiply across, you can put in some parentheses if you'd like to indicate that we're multiplying the numerators and the denominators. In the numerator, let's see, we get 3 distributed to both 6 and a minus 8i. That's going to be 18 minus 24i. Multiplying in the 4i would give us 24i. Okay, 4 times 8, that's 32i squared. Great. In the denominator, we have 6 multiplied in gives us 36 minus 48i. Multiplying in the 8 gives us plus 48i, and then minus 64i squared. All right, combining like terms. In the numerator, we have 18. The 24 i's cancel. I squared is negative 1, so we actually get plus 32. In the denominator, we have 36. The 48 i's cancel, and we have a 64i squared. That's a negative 64i squared, becoming a positive 64. So there are no imaginary numbers anywhere within this problem. We can just simply add the numerators and denominators together. So we get 50 over 100, or a half. To solve this equation, we're going to factor, and hopefully this is going to be easy enough just to guess the answer. If we do this, we have to have x and an x, as well as a positive and a negative. If we want to multiply to 18, I think I want to use 6 and 3. Those not only multiply to negative 18, but it adds to a positive 3. And this means the solution to the equation is going to be, if I look here, x is equal to negative 6, and also x is equal to positive 3. Those are the two solutions, and you can check this on your graph. This one's a little different because there's only 2 terms, but that actually can be a nice thing when solving a quadratic because it's not really hard to guess the factors. You can simply just remove the greatest common factor from both terms, which appears to be a 2 and an x. What I mean by this is, if you factor out 2x from both terms, you're left with an x and a minus 7. You can even check to see if this is right by distributing the 2x back into the parentheses. 2x times x is 2x squared. I have a minus, and then 2x times 7 is 14x. So from here, I can now note that, clearly x equals 7 is a solution, but if you ever have just an x by itself, that must mean the solution is x is equal to 0. if you put 0 right here, it makes this factor 0, meaning the whole side is 0 as well. For this problem, what we want to do is set it equal to 0. That'll be our strategy for solving any quadratic. So I'm going to subtract 17x from both sides. We don't have any like terms, so I can write this as x squared minus 17x plus 70 is equal to 0. Again, I'm trying to guess what those factors are. They both have to be x minus. That's how you can multiply to a positive yet add to a negative. And clearly this is going to be 7 and 10. The product is positive 70 and the sum is negative 17. Therefore, by observation, I know that x equals 7 is the solution, as well as x is equal to 10. Okay, to solve this quadratic, it's already set up so it's equal to 0. They both have to be x plus. Okay, two numbers that multiply to 36 yet add to 13 are going to be 9 and 4. 9 times 4 is 36, 9 plus 4 is 13. Therefore, my solutions by observation are a negative 9 and also a negative 4. I think I want to subtract 9x from both sides. Clearly, we're going to subtract 36 as well. All I'm really saying is we're rewriting this equation to be x squared minus 9x minus 36 is equal to 0. Hopefully we can guess the factors from this. All right, so two things that would multiply to negative 36 yet add to a negative 9. Okay, you have to have an x plus and an x minus. Okay, I think it's got to be 12 and 3. It's got to be a positive 3 and a negative 12. The product is definitely negative 36, and okay, yeah, the sum is also negative 9. Therefore, we have x is equal to negative 3, and x is equal to positive 12. The second, you no longer have just an x, but like a 2x squared. It makes guessing a little bit more difficult. If you're trying to guess the factors, if it's going to work out nicely, it's got to be like 2x and x. And we want to choose something where it would multiply to a negative 5, yet add to a negative 9. But this 2 here is going to cause some issues. We could go case by case, but I'm thinking if we had 2 times a 5, that would be 10, and a negative 10 is relatively close to negative 9. I think I want a minus 5 here and a plus 1 here, and the reason for that is this 2 times that 5 gives me a negative 10x. This 1 times this x gives me a positive 1x. The sum of those two numbers is a negative 9. So you could actually go through and check to see that this multiplies back to the previous step. I'm confident it does. 2x squared times x, 2x times x is x squared with a 2 in front of it. A 1 times a negative 5 is negative 5. And the middle terms multiply to give us a negative 9x. This means my solutions are, this one's obvious, x is equal to 5. This one here, it's going to be x is equal to negative 1/2. If you have a number in front of the x, it'll always appear within the denominator of your answer. So that is, if you have a 2 here and a 1 here, the 1 goes in the numerator, the 2 goes in the denominator. I know that the sign here has to be different. If this is positive, that's negative. Like if this is negative, that's positive. But this is my answer. Okay, for this one, I'd like to start by, adding 3 to both sides. I'm going to add 3. Changing this to 4x squared minus 8x plus 3 is equal to 0. So when it comes to trying to guess factors for this, I have to have, well, let's see, it's got to be x minus, and now it's kind of tricky because, well, is it going to be like 2 and 2, or maybe it'll be like 4 and 1? I'm going to guess 2 and 2, only because the middle number, it's not very large, but I don't know, let's see. Well, there's not a whole lot of options at this point, right? It's got to be a 1 and a 3. It doesn't matter where the 1 and the 3 go because they both have a 2x and a minus. This would be the only case to consider. 2x times 2x gives me a 4x squared. A negative 1 and a negative 3 multiplies to a positive 3. We just have to make sure we're getting this negative 8. And again, where that is coming from is you would do the outer 2x times negative 3, which is a negative 6x. You would then multiply your inner terms, the negative 1 and the 2x, which is a negative 2x. It would have to be that these two sum to negative 8. And as a matter of fact, they do, right? Negative 2x minus 6x is negative 8x. I'm convinced that we have this correct. Now, to guess our answers, like I said before, for 2x minus 1, I know the answer has to be positive, and it's going to be 1 over 2, where this negative meant the answer is positive, this 1 goes in the numerator, this 2 goes in the denominator. Likewise, over here, the solution has to be x is equal to, it's got to be positive, 3 over 2. And those are my answers. Okay, so this one's set up already equal to 0. I'm going to try to guess the factors. Because the middle term is a negative 27, instead of guessing 2x and 2x, I'm thinking it's probably got to be something more like a 4x and an x. This might not be the case, but this is where I'm going to start. And we want the last term to be, since it multiplies to a negative number, we have to have a mix of positive, negative, or negative, positive. And it matters where it goes this time. There are cases to consider. I'm going to go negative, positive. And the reason for this is 4x gets multiplied to a number here. And I know my middle term is positive. I need the net result to be a positive answer. So the 4 multiplying to a positive number here is going to give me a larger value. And now I just need two numbers that multiply to give me negative 7. And my only options are 1 and 7 if it's going to work out nicely. So I'm thinking it's got to be 1 and 7. I know the first and last terms work, right? 4x squared is okay because you have 4x and an x. Negative 7 is okay because I have negative 1 and positive 7. I just need to ensure that if I take my outer terms and my inner terms, it's going to balance to give me a positive 27x. The inner terms give me negative x. The outer terms give me 28x. And yes, the sum of those two things is positive 27. I can now say that my solutions are going to be a positive 1/4 as well as negative 7. For the next problems that appear, I'm asking to solve quadratic equations using this formula. So if we look at 29, we want to solve x squared minus 7x plus 6 is equal to 0. And if your equation is written exactly in this form, you have to identify a, b, and c and plug it into this expression and simplify it. And this one is ready to go. The coefficients are a is equal to 1, b is equal to negative 7, and c is equal to positive 6. Let's plug it in and see what we get. X is equal to negative 7 plus or minus the square root of negative 7 squared minus 4 times 1 times 6 all over 2 times 1. And I'm just going to simplify this in my calculator. Okay, what I got was x is equal to, this is really 7 plus or minus the square root of 25 over 2. So a little bit of work there, but you can pretty much type most of this into your calculator. This is x is equal to 7 plus or minus 5 all over 2, which means we have two solutions. We have x is equal to 7 plus 5 over 2, as well as x is equal to 7 minus 5 over 2. This one up here, it's going to be 12 over 2, which is 6. And the second one is going to be 1. So those are the solutions to the original equation, 6 and 1. All right, for this problem, I'm going to start by adding 10x to both sides, because this has to be written in the form x squared plus 10x plus 25 is equal to 0. I now note that a is equal to 1, b is equal to 10, and c is equal to 25. I'm going to put all of this into the quadratic formula. X is equal to negative 10 plus or minus the square root of 10 squared minus 4 times 1 times 25, all over 2 times 1. And let's simplify this. This is negative 10 plus or minus the square root of 0 all over 2. If your square root is 0, there's no need for this plus or minus. This is really just negative 10 over 2. In fact, there's just one solution. X is equal to negative 5. So anytime that your square root vanishes, this plus or minus vanishes as well, meaning there's only one solution to your equation. This one's already set up for us, but a is equal to 6, b is equal to 11, and c is equal to 3. This means x is equal to negative 11 plus or minus the square root of 11 squared minus 4 times 6 times 3, all divided by 2 times 6. So let's simplify this one. This is negative 11 plus or minus the square root of 49 all over 12, or x is equal to negative 11 plus or minus 7 all over 12. Meaning, again, we have two solutions. X is equal to negative 11 plus 7 over 2, and x is equal to negative 11 minus 7 all over 2. Just a quick correction here, that was actually supposed to be 12. I copied that down wrong, but anyway, when I plug these in, I'm going to write my answers as, let's see, for this one here, it's going to be negative 1/3. And for the second one, that's also negative, and that's negative 3/2. And those are my two solutions. Okay, for this one, I'm going to subtract x and 1 from both sides. And I'll just rearrange it to say this is x squared minus x minus 1 is equal to 0. A is 1, b is negative 1, c is negative 1. The solutions are x is equal to negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1, all divided by 2 times 1. This simplifies to 1 plus or minus the square root of 5 all over 2. I would actually leave my answers like this. You could break it apart into 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. But since the square root of 5 can't be, it's not an integer, it's a decimal, these are your exact answers. This one would be pretty easy to solve without using the formula, but the point is to actually plug things into this expression. After I subtract 4 from both sides, I have 2x squared minus 4 is equal to 0. I'll note that a is equal to 2. There are no x's, meaning b is 0 and c is negative 4. So we get negative 0 plus or minus the square root of 0 squared minus 4 times 2 times negative 4 all over 2 times 2. So x is equal to negative 0. I do not have to write, but we do get plus or minus, and we have the square root of negative 4 times 2 times negative 4. That's the square root of 32 all over 4. Now, you could be a little bit clever when simplifying this. If you type in the square root of 32, it's not going to work out nicely. It's not going to be a value that's an integer. But if you look at 32, it's worth pointing out that this thing is 2 times 16. So if you take the square root of 32, you're really taking the square root of this product. You can't do anything with the square root of 2, but the square root of 16, well, you can do something with that. That's equal to 4. I'm going to replace the square root of 32 with the square root of 2 times 16. So this is plus or minus the square root of, and I'll put 16 times 2 all over 4. The reason for doing this is you get plus or minus, the square root of 16 is 4. I'm not going to do anything with the 2. And I'm noting now that, wait a minute, there's a 4 in the numerator and the denominator. Here are my answers, plus or minus the square root of 2. Okay, so for this one, I'm going to subtract 2x from both sides. I'm also going to subtract 2. So we're changing this problem to x squared minus 2x minus 2 is 0, meaning a is 1, b is negative 2, and c is negative 2. My solutions would have to be negative 2 plus or minus the square root of negative 2 all squared minus 4 times 1 times negative 2, all divided by 2 times 1. Let's simplify this. All right, so we get 2 plus or minus the square root of 12 all divided by 2. So here we have a situation again where, all right, I have 12 under the square root, but you can break this apart into 4 times 3. And the reason for doing this is, well, if you take the square root of 12, it's really the square root of 4 times 3. Square root of 4 reduces to 2. you can't do anything with the 3. So I'm going to replace the square root of 12 with 2 times the square root of 3. So x is equal to 2 plus or minus 2 square root of 3 all over 2. That 2 can be divided to both terms in the numerator. Here we're left with 1s. Here we're left with just the square root of 3. These are the two answers, 1 plus or minus the square root of 3. Okay, solving this one, I note that a is 1, there are no x's, so b is 0, and c is 4. So x is equal to negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 4 all over 2 times 1. So this one is odd in that it's plus or minus, and you get the square root of negative 16 all over 2. Okay, if you type this into your calculator, it's going to give you an error message, which means there are no solutions, no real solutions to this equation. However, anytime that you see a negative under the square root, we define that to be I. You can rewrite this problem as plus or minus the square root of 16 times I over 2. And furthermore, 16 now can be reduced to 4. So off to the side, I'm just going to note that if you have the square root of 16 over 2, well, that's really 4 over 2, and that's just 2. The solutions are plus or minus 2i. The I at the end is just to indicate that we had a negative under the square root, meaning these are imaginary solutions. They will not appear if you put this into your graphing calculator. All right, for this one here, I think I'm going to add 17 to both sides. And we get negative 6x squared plus 17 is equal to 0. You could have added the 6x squared to both sides, but I thought I'd try it out this way, where a is equal to negative 6. There are, again, no x's, and c is equal to 17. The solutions to this equation would have to be, I'm not even going to write the negative 0 this time. It canceled every time. So you get plus or minus the square root of b squared. I'm not going to write that either, but you get minus 4 times a times c all over 2 times negative 6. I left the b's out because they're 0. Okay, so underneath the square root, that's negative 4 times negative 6 times 17. That's 408. So this is plus or minus the square root of 408 divided by negative 12. So the square root of 408. Let's think about how we could break this one apart. All right. If I look at 408, I can definitely divide it by 4. I'm looking for things that are perfect squares, and 4 is definitely that. And on the other side, we get 102. All right. Can I divide something into 102 that's a perfect square? So 4 doesn't work. Clearly 9 is not going to work. I mean, if 4 didn't work, 16 isn't going to work. That thing can't be reduced. So this means if you take the square root of 408, you're really taking the square root of 4 and 102. And the square root of 4 is 2. This is x is equal to plus or minus 2 the square root of 102, all divided by negative 12. And 2 can cancel to give us a 6. So this is going to be plus or minus the square root of 102 over negative 6. And if you were to move this negative over here, you would still have a positive and a negative solution. So negative in the denominator really isn't telling us very much here if you already have a plus or a minus. This means your answers are simply plus or minus the square root of 102, all divided by 6. All right, this one's set up nicely for us where a is equal to 1, b is equal to negative 2, and c is equal to positive 5. So my solutions are negative 2, plus or minus the square root of negative 2 squared, minus 4 times a times c, which is negative 4 times 1 times 5, all divided by 2 times 1. So let me simplify this. Okay, we get 2 plus or minus the square root of negative 16 all over 2. And we're running into the situation again where we have another negative 16. I know that's going to be, the square root of 16 is 4, and the negative 1 gives me I. So just working across here, this is 2 plus or minus 4I divided by 2. And this 2 can be divided into both of those terms, which gives me a 1 here, it gives me a 2 there. These are my two solutions, 1 plus or minus 2I. Okay, I'm going to subtract 10x from both sides, and I'm going to reorder this, so it's x squared minus 10x plus 26 is equal to 0, meaning a is 1, b is negative 10, and c is positive 26. My solutions are going to be negative b, negative 10, plus or minus the square root of negative 10 squared minus 4 times 1 times 26. And this is all divided by 2 times 1. If I simplify this, I get 10 plus or minus, all right, that is 100 minus, do this one out, so that's negative 10 squared minus 4 times 1 times 26. Yeah, it's negative 4. All over 2. So here we have another negative, again, under the square root. The square root of negative 1 is the I. The square root of 4 is 2. I can write this as x is equal to 10 plus or minus 2I over 2. Again, I can divide this 2 into both terms in the numerator. This gives me 5 plus or minus I. Those are my two solutions. To solve all of these by completing the square, I'm going to replace the function notation with a y. So really what I'm working with is, in each example, y is equal to some type of quadratic equation. And for this one, you could start by subtracting 4 from both sides, but maybe you already noticed that the right side of this is actually already a perfect square. If you think about it, if you were to square x plus 2, the x squared gives me x squared, the 2 squared gives me 4, and if I double the middle terms, you get a 4. So this is actually it. I just completed the square on this equation. I didn't ask for the vertex, but I think it's worth writing down for these problems that the vertex is going to be negative 2, 0. The graph moved 2 places to the left. It did not go up or down because there is no number at the end, and that is the solution. Now for 40, okay, so this is no longer a perfect square. If we're using the approach from last time, we're going to start by subtracting 5 from both sides of the equation. So we now have y minus 5 is equal to x squared. I'm actually going to leave a little bit of room here, but we get x squared plus 4x. The goal is to now add something to both sides to create a perfect square, and I look here to do that. If you take half of 4, you get 2, and if you square 2, you get 4. I'm going to add 4 to both sides of this equation. In doing so, on the left we get y minus 1 is equal to, and on the right, I know this is a perfect square. All you have to do now is just add 1 to both sides. And this is my solution. Y is equal to x plus 2 squared plus 1. I think I'll note that the vertex is negative 2, 1. The graph moved left 2 and up 1. Okay, if we look at 41, let's see. Again, this is y is equal to, okay, x squared minus 10x plus 1. I'm going to subtract 1 from both sides. And this gives me y minus 1 is equal to, again, maybe I should leave some room here. Okay, this is y minus 1 is equal to x squared minus 10x. I'm looking at this negative 10. I'm taking half of it, it gives me negative 5. And if I square negative 5, I get 25. That is the number I add to both sides of my equation. We get y plus 24 is equal to, and my perfect square has to be x minus 5. After subtracting 24 from both sides of my equation, I have my answer. Y is equal to x minus 5 squared minus 24, meaning the vertex is equal to 5, negative 24. We went 5 to the right and down 24. Okay, we'll start by adding 11. We get y plus 11 is equal to x squared minus 36x. Again, focusing on that negative 36, if we were to take half of this, we get negative 18. And then squaring negative 18, we're always going to get that positive number here, 324. That's the number I want to add to both sides. So I'm going to do 324 added to both sides. And now, if I combine like terms, I get y plus 335 is equal to x minus 18 squared. If I subtract 335 from both sides of my equation, I get my answer. Y is equal to x minus 18 squared minus 335, meaning the vertex is equal to 18, negative 335. Okay, this one's z instead of y, not that that really matters, but same thing, I'll add the 41 to both sides. This changes to z plus 41 is equal to x squared plus 100x. I'm focusing on this 100 because half of that is 50, and 50 squared is 2,500, that's right. That's what I'm adding to both sides of my equation, 2,500. In doing so, on the left I get y plus 2,541 is equal to, okay, this has got to be a perfect square. It is x plus 50, and that makes sense. If you double 50, you get 100. If you square 50, you get 2,500. I now subtract 2,541 from both sides, and I have my answer. Z is equal to x plus 50 squared minus 2,541, meaning the vertex is at negative 50, negative 2,541. For this one, not only do we have to subtract 1 from both sides to give us y minus 1 is equal to 2x squared plus 12x, but we're also going to divide both sides by 2. And the reason we're doing this is to cancel the 2 in front of the x squared. This gives us y minus 1 over 2 is equal to x squared plus 6x. So now we can look to this 6 to figure out what to add to both sides. We take half of 6, and that gives us 3, and 3 squared is equal to 9. So we'll put plus 9 on both sides, and what we're left with is y minus 1 over 2 plus 9 is equal to, and the right side's a perfect square, it's going to be x plus 3 squared. I'll then subtract 9 from both sides, so we get y minus 1 over 2 is equal to x plus 3 squared minus 9. I'll now multiply both sides by 2, so we get y minus 1 is equal to 2 times x plus 3 squared minus 18, and then I'll add 1 to give y is equal to 2 x plus 3 squared. Adding 1 gives me minus 17, and that means my vertex is equal to negative 3, negative 17. Okay, so the variable here is t, but the idea is the same where I'm going to subtract 7 from both sides. So we get y minus 7 is equal to 2t squared minus 16t. I'll then divide both sides by 2. And we get y minus 7 over 2 is equal to t squared minus 8t. I can now look here to say, okay, I'm going to take half of this to get negative 4, and when I square negative 4, I get positive 16. Therefore, I am adding 16 to both sides of my equation. I get y minus 7 over 2 plus 16 is equal to, and this has got to be t minus 4 squared. I'll now subtract 16 from both sides. multiply both sides by 2, and then add 7 to both sides. Vertex for this equation is going to be 4, negative 25. Okay, let's add 1 to both sides of this equation. And then divide both sides by 2. And we get y plus 1 over 2 is equal to x squared plus 5x. Now for this one, when I take half of 5, you could either leave it as a fraction or even use a decimal, like that would be completely okay. But if you square 2.5, that's going to be 6.25. This is what I'm going to add to both sides. And the reason this works is, on the left, we have y plus 1 over 2 plus 6.25 is equal to, on the right, I get x plus 2.5 squared. I now subtract the 6.25. I now multiply both sides by 2. So that's going to be 12.5. And then I subtract 1 from both sides. And this means my vertex is at negative 2.5, negative 13.5. So for this one, I don't have to add or subtract anything to both sides, but I can divide both sides by 3. In doing so, I get y over 3 is equal to z squared plus 10z. I now take this 10, take half of it, and square it, which gives me 25. This is what I add to both sides. I get y over 3 plus 25 is equal to, this has got to be z plus 5 squared. I will then subtract 25 from both sides, and then multiply both sides by 3. And that's my answer. So here the variable is theta. You could just replace it with x if you wanted. I'm going to subtract 2 from both sides and divide both sides by negative 1. That means I get y minus 2 divided by negative 1. And on the other side, I get theta squared minus theta. So I have this 1, a negative 1, that is in front here, which means I get negative 0.5. And if I square negative 0.5, I get a positive 0.25. And that is what I'm going to add to both sides, 0.25. And this gives me y minus 2 over negative 1 plus 0.25 is equal to theta minus 0.5 squared. I'll subtract 0.25 from both sides. Multiply both sides by negative 1. And then add 2 to both sides. So here my vertex is kind of running out of room, but the vertex is at 0.5, 2.25. And for the one up here, I forgot to write that up, so I'll just put the vertex is at negative 5, negative 75. To solve 2x squared plus 7x minus 4 is greater than 0, I'm going to start by figuring out where it is actually equal to 0. So I want to see if I can try to factor this thing. Like, where are the factors of it? If I can guess the factors, we have to have 2x and x. And if we want to end up with a negative 4, I'm going to try plus 4 and a negative 1. That works. The middle term is going to be a positive 8x and a minus x. My two solutions are x is equal to a half and x is equal to negative 4. So if I graph this thing, like this is what I'm just doing directly in my graphing calculator. I graph the equation and it's going to go through negative 4 and a half. So you should see something that looks like this. So this is negative 4, that's positive 1/2. Where is 2x squared plus 7x minus 4 greater than 0? Like that's the ultimate goal. 2x squared plus 7x minus 4 greater than 0. I can see that that's referring to this portion of the graph and this portion of the graph. So our options is either between those two values or on the outsides. Clearly it's on the outsides, and that gives me my answer of x is less than negative 4 or x is greater than a half. You could use, again, intervals and say from negative infinity to negative 4 and from 1/2 to positive infinity, but both of those are completely acceptable. So we'll do the same thing for 50, where, okay, we want to figure out where x squared plus x is less than or equal to 72. Well, a good place to start is to figure out where it's actually equal to 72. So I'm going to subtract 72 from both sides. And I wonder if we can factor this thing. I'm guessing we can. Okay, that's x and x. You gotta have a positive and a negative. Okay, that's going to be 9 times 8 is 72. So I want a positive 9 and a negative 8, meaning my solutions are negative 9 and positive 8. The rest is done on my graphing calculator. I have one solution that is at negative 9, another one that is at positive 8. I had to zoom out a little bit to get the graph, but it comes down like this, and eventually it comes back up like this. And our goal is to figure out where is x squared plus x less than or equal to 72, which is equivalent to saying where is x squared plus x minus 72 less than or equal to 0. Less than or equal to 0 is referring to this portion of the graph. So like really all you have to figure out is, again, am I between the two numbers or on the outsides of them? And for this one, the answer is from negative 9 to positive 8. Or you could use this interval if you would like. I'm seeing that I have an equal sign on the answer, so really that should be a bracket to indicate that I'm including both negative 9 and 8 in my answers, but that's it. So for this one here, it's kind of tricky, but I want to figure out, well, again, equals. What I'm going to do is divide both sides by 25, and I get 1 over 25 is equal to x squared. And if I take the square root of both sides, I get x on one side, and then plus or minus, if you do the square root of 1 over 25, the square root of 1 is 1, the square root of 25 is 5. There are your two answers, positive a fifth and negative a fifth. So if you were to graph this thing, and you want to know the solutions to this equation, let's see, we get a couple of numbers that are very close to 0. So what I'm going to graph is where is 25x squared minus 1 less than or equal to 0? I get negative a fifth and positive a fifth is where they're equal to 0. But the graph lower than 0 means I'm between the two values. So the solution here has to be between 1/5 and negative 1/5. And I'm including both of the endpoints, so here's my answer. Or if you'd like, negative 1/5 to positive 1/5. And for the last one, for 52, I want to figure out where is x squared minus 5 less than 4x. Again, it might be worthwhile changing it so one side's equal to 0, so I'm going to subtract 4x from both sides. Where is x squared minus 4x minus 5 less than 0? So I first want to figure out where it is 0. So I'll have x. I have to have a positive and a negative. I want a positive 1 and a negative 5, meaning my solutions are x is equal to negative 1 and x is equal to positive 5. So if I go to graph this thing, my two solutions are at negative 1 and positive 5. It's a quadratic going between those 2 points. And less than 0 means, okay, I've got to be between these two values. So that is my answer. Everything from negative 1 up to positive 5, or you could use this notation as well.